What's going on, guys? Welcome back to this channel that's all about architecture, engineering and construction, and where we're also all about bettering the African narrative. Yes, so in this video we are going to be discussing the costs of building this 4-bedroom house. It's actually a 4-bedroom house. It's a semi-storied house, which means that part of it is bungalow and part of it is a storied house. Now, this is a design that we usually adopt when we want to minimize on construction costs and yet still have the experience of sleeping upstairs or having some upstairs space. Okay, so anyway, in this video we are going to be discussing the costs, the quantities of things that are required at every stage of construction, and along the way we'll also be discussing the different tips on the best industry practices for construction. Because there are many things that are really taken for granted and those that are used along the way that are not even necessary. You see, I always say in my videos that when you understand why certain things are done in a certain way, you might end up doing things religiously even where you shouldn't actually be doing them, and that sometimes can actually be costing you a lot. Okay, so in this video we are here to know the costs of building this house, and along the way on probably every item where necessary we'll be breaking down whether it's necessary, whether it's a worthwhile recommendation or not for at least each of the materials. I'll give an example of things like hoop iron. Some of you know hoop iron, others don't know, but we'll just have a picture or a video on the screen as you can see hoop iron. So there are people who actually mess up when it comes to construction and they don't even include hoop iron in their substructure walls, even actually in the superstructure walls. But the function of hoop iron is actually to take the tensile forces in the brickwork. You see, when you lay down the bricks, usually in the plinth wall, that is in the foundation wall, okay, you realize that when you lay after every few courses of brickwork, you have to put hoop iron. So this hoop iron actually helps in reinforcing the brickwork so that it can take up the tensile forces. So in a scenario where you have an unstable foundation, when you have uneven settlement of the foundation, that is when you realize that this hoop iron that you actually put in those courses is going to take up those tensile forces and is going to prevent the bricks from cracking. So it literally helps the structure act as a whole, so that all the assembly of brickwork is actually acting in unison. In that way, the building becomes less likely to buckle or to crack in case there is an uneven settlement in the foundation. You see that quite a lot in many areas where people are building and they don't consider this. Okay, anyway, and also the other way that this can be achieved, most of you see that for the projects that we've been doing here and there, you realize that we usually cast the slab before we even do the walling. Of course, some people really usually do the brickwork and finish the whole superstructure, finish the whole shell, and then they come and cast the slab later. The reason why we cast the slab at an early stage is so that we can literally cover all the walls, so that slab carrying the loads of people and beds and tiles and all that, all the loads are actually uniformly distributed onto the plinth wall, so they help the structure act in unison. Of course, there are many other reasons why we do that. One of them is also the waterproofing, which I think I've talked about before. It's very important so that when you cast all the slab at once, you actually cut off the supply of water by capillary to the superstructure, which is usually one of the major leading causes of peeling walls. Of course, there are many other things that we need to talk about when we go into a topic like that, like waterproofing the slab itself, like also using the DPMs and things like that. But anyway, I'm not here to discuss all that at length, but that is very important. So in this video we are going to be discussing the different costs. Now, as you can see on the screen, I have already projected the screen of the different costs that we are going to be incurring them. I'm going to help you understand the way in which we've broken them down for every stage. For example, for the foundation, then for the superstructure, that is the walling, and then also for the slab, the first floor slab. Okay, we have divided them into phases of for example, you can see that here, while you're on the foundation, we have concrete works. Down here we have steel works, as you can see on the screen, and down here we have carpentry works, and then we have plumbing works. Okay, so that means by the time someone does the substructure of the building, you all have all these things arranged in this format. At some way, all the materials that we have can be categorized into these different subcategories that we have. Okay, so starting with the concrete works. Now the concrete works have to do with the pad footings, also the starter columns in the foundation. Okay, so in this scenario we are talking about the part of the house that is going to be storied. So when the foundation is being done, the part that is actually going to have the storied bit is going to have columns that are coming straight from the ground. So as you can see on the screen, I will not be going on to them one by one, but as you can see them on the screen. Then there are some other things that we have actually included that you might not be able to understand, but I will explain them to you along the way. So in these columns, we have one column for items, we have another column for units, we have another column for the quantity, we have another column for the rate, and we have another column for amount, and then the accumulated total. Now the accumulated total is the total summing up all the things that we will have covered at any particular stage. Okay, for example, as you can see on the screen, if we go down and we find that the concrete works for the foundation cost about 13 million, you see that the total here is 13.8 million. That means I have summed up what we had used in setting up. I have added the total of the concrete works, and that gives us about 13.8 million. So I hope that is clear. You can easily follow through as we are discussing all these. Then also probably anything else that I need to explain that you might need to understand, I'll be sharing it with you along the way. First of all, the house that we are talking about is a semi-storied house. It has 180 square meters of space, that is as a footprint on the ground. Okay, then upstairs we have about 85 square meters of space. And then also, if you are looking at the general dimensions of the house, we have about 16 meters by 15 meters roughly. Okay, that is in terms of the footprint of the house. So this house unfortunately cannot sit on a 50 by 100 plot, because whenever you're building and you're capitalizing more on space that is on the ground, you use a lot of space on the ground. So when you have a small plot, you're not able to take advantage of space maximization. Okay, so unfortunately the minimum land this can sit on is probably 80 by 100. And then I've explained before why in some scenarios you choose to have a semi-storied house. But then, so heading right into the video, you see we have concrete works for the foundation. Now this foundation includes the pad footings, it includes the strip foundation, it includes the starter columns that are actually below the slab, it includes the ground beam as well, and the plinth beam and the plinth wall and the ground slab as well. So literally everything. By the time we finish this part that you see here that is labeled B, it means that we'll have finished casting the slab. So I want you to follow through closely. And also when we are giving these figures, we only talk about material costs. Okay, we are not talking about the labor expenses, because those vary largely depending on who is actually building for you. Okay, another engineer can charge you another amount, another one can charge you another amount. So there's really no standard for labor depending on who is actually going to build for you. So we talk about cement, we talk about lake sand. We are counting lake sand in terms of sino trucks. I've explained before why sometimes you choose to use sino trucks, is because whenever you use sino trucks, you actually get more economies of large scale. For example, on every sino truck, you might realize that you're getting an extra 1 to 2 to forward trucks of sand or whatever material it is, because you're actually saving. Yeah, but when you're buying things in small bits and just buying forward trucks here and there, you realize that you're actually spending more on materials than when you just got a sino truck as a whole. Okay, so I'll also be mixing them along the way, because you might realize that a certain stage might need not exactly a full sino truck, but where there is excess, we have carried it forward to the next stage. So in some stages you might see half a sino truck or something of the sort. So here we have cement for the concrete work specifically. We have cement, we have Dr. Fix-It waterproof. Now this one right here is not really compulsory, that Dr. Fix-It waterproof. It is only just a recommendation because it helps in waterproofing that slab. Okay, so that there will be no leakages of water by capillary to the superstructure. Then we have aggregates. That's just about 1.5 sino trucks. That is literally for the ground, for the foundations and all that, and including the slab as well. And some aggregate is going to remain. So as you follow through, you might reach on the superstructure and we might not put aggregate because we have a balance of aggregate at this stage. So we have the DPM. The DPM is the damp-proof membrane. We have 5 rows, 500,000. Then we have things like maram. You see that on maram I've put 0. Maram is not really usually necessary. most especially when you have done proper leveling of the compound. You still have some excess of soil on the compound, so that you can actually backfill using that soil rather than buying maram. Then we also have hardcore. Now hardcore, it is not in every scenario that you need hardcore. Like I said previously, when you understand these things, sometimes you can learn to avoid certain things. If you literally have very stable soils and you've not done a lot of backfilling, you might not need hardcore, and usually when you have smaller spaces. So the function of hardcore has basically two functions. The first function of hardcore is to cut down the capillary forces from the ground reaching to the slab. That one, engineers might understand it. Even those who are not engineers, you know that whenever you have a lot of large pores, it prevents upward movement of water. That is why we do hardcore at that stage. Then the other reason why we do hardcore is because hardcore creates that strong base where the slab is going to sit. So if you have unstable soils that are probably expansive, or soils where you've done a lot of backfilling and the compaction is not really as sufficient, that hardcore actually helps to create a strong ground on which the slab can sit. Remember, the ground slab is an unreinforced slab, which means there are no iron bars in that slab. It is purely plain cement concrete. So when we are having that slab, we need to make sure it is sitting on a very strong ground where it cannot easily just buckle or sink in along the lifetime of the building. Okay, so heading down to the steelworks, we have 12 millimeter bars, we have 16 millimeter iron bars, we have R7 and R8 rings. Now those ones are a bit separate. The R7 are to be used in the ground beam, and the R8 are to be used in the columns, in the starter columns, straight from the foundation. Then for BRC, according to the design that we have, we are using A66. There are different types of BRC. There is A66, there is A142, there is A98. They are really different. This one seems to be the most, I think, one of the least strong. But for the design that we have, this is really sufficient for it. So we need about 3 rolls of that, or 3 pieces, and that is about 900,000 in total. Then we have binding wire. Most of you know what binding wire is. That is used to tie those reinforcements together, tying the iron bars together. So the total for steelworks brings us to 7.24 million. Then we have carpentry works. Okay, under carpentry works we have 9x1 timber, which is famously known as Chirundu here in Uganda. Then we have poles, we have 4x2 timber, we have nails. Okay, those different carpentry works are basically for doing formwork for the columns, and also doing formwork for the slab as they're actually casting it. Okay, so all those together bring us to a total of about 22 million. That means we have included everything up. Okay, of course there are costs that I've not included, that if you're budgeting you need to include them. But the reason why we don't include certain costs is because they vary from one side to another. For example, we've not included the costs of hoarding. Hoarding is actually those iron sheets that you see around the site. They give kind of a controlled access to the site, so that when you have your materials and your construction work that is going on the site, not everyone has access to the site. Okay, so sometimes it's necessary to hoard the site, or when you already have a boundary wall, you don't need to do the hoarding. Then also things like water, provision for water on site. Basically those setup costs, also setting up like a storehouse where some of those materials will be stored during the construction project. Those are things we've not included here. So anyway, going forward to B4, B4 is actually masonry work. So masonry work is we have clay bricks, we have the hoop iron, whose role I've already explained, we have lake sand, we have cement, and then the total we have for that is 9.56 million. Now in this scenario I've considered clay bricks. Okay, so someone might actually choose to have the red burnt bricks instead of having the clay bricks. The difference between the two, maybe I'll just put pictures on the screen so that you can be able to see and differentiate between the two. Because the red burnt bricks are actually 250 shillings each, about 220 to 250 shillings each, the good ones. But for clay bricks, they are much stronger, they have more water retention capabilities, they have better water retention capabilities. So they are about 350 shillings per brick. So we have the total to that. Then for plumbing works, you can see not available. That means for the design that we have, there is nowhere that we've designated any pipes to run underneath the slab. So at this stage of construction, we literally do not have any plumbing works. Okay, So with all the slab being complete, it's getting completed at around 32.4 million. Then we go to the superstructure. The superstructure involves the walls and the columns. This is pretty much straightforward. So we have for the concrete works, that is for the columns specifically, we have cement, we have lake sand, we have also we have coarse aggregates. Now you can see on this stage the lake sand we have put 0, which means in the sino trucks that we bought before in the earlier stages, we considered that the 1.5 sino trucks are going to be sufficient for both doing the foundation and also doing the columns for this stage. That is why we do not have the lake sand involved at this stage. Okay, so going to the steel works, we have 12mm iron bars. As you can see here, we do not need any for this design that we have. Then the 16mm bars, which people call Y16, we need 22 pieces. Then we have R8 rings, we have binding wire, and all that brings the total to 2.6 million. Then also talking about the carpentry works, that is the timber that is actually used to shatter the slabs, the columns. Yes, we have 9x1 timber, that is Chirundu, we have poles, we have 4x2 timber, we have nails and all that. Then do the masonry work is where we actually now bring in the blocks, the 150mm blocks for this design specifically. Other designs might require that you use 200mm blocks. For those of you who might also be users of inches using the American system, 150mm is 6 inches and 200mm is 8 inches. So when I say 150mm hollow blocks, I mean 6-inch hollow blocks. When I say 200mm hollow blocks, I mean 8-inch hollow blocks. Okay, so we have hoop iron, as I've already explained before. We have lake sand, we have cement as well, and the total for all that is bringing to around 11.9 million. So right now the total for the slab and the walling and the columns and all that is coming to 49 million. Then going now to the superstructure. Remember, this is semi-storied, so the part of the slab is not really that much. Okay, we only have about 2 bedrooms. We actually have only 2 bedrooms upstairs that are actually self-contained. Okay, if you also include that the space that is taken up by the staircase and all that, and also the small balcony. So anyway, let's look at the figures. Okay, so we have concrete works, we have cement, we have lake sand, we have aggregates, coarse aggregates, and all those are bringing us to a total of 6 million. Then we have steel works, that is the 12mm iron bars. Okay, those are mainly for the slab. Then we have the 16mm iron bars, those are mainly for the beams. And then we also have the R8 steel bars. Then we have the binding wire and we have the rolls. We have the binding wire, so we have 6 rolls. Okay, so we have carpentry works, the 9x1 timber, the one like I said, the Chirundu. We have poles, we have 4x2 timber, we have 6x2 timber. This is mainly for the staircase, for making those risers and the treads of the staircase. Then we have nails as well. All that brings to 7.36 million. So the total for all that. We have other works. Okay, we have DPM. The DPM is that polythene sheet that we actually put right before casting the slab, so that it helps the slab in retaining water during the hydration process of cement or during the hardening process of cement. That is for the slab. So we also have max span, since we have most of the slab work being hollow slabs. So the total for that is coming to 2.4 million. So right now where we are at, we also include the plumbing works. When we are doing the slab, it's very important to take these plumbing works seriously, because at this stage, if any mistake is done, it's quite costly or risky to actually correct. So we have the 4-inch pipes, 2.5-inch pipes, and all that. As you can see, the total brings that to 330,000. Then we also have electrical installation works. That is, we have 32mm conduits. We have couplers. Couplers are those things that join conduits. When a conduit is short, like the standard length of a conduit is about let's say 8 feet, and then you want to just join the conduits together, so you need couplers to join them together. Okay, so those are couplers. We have PVC cement, we have circular boxes and all that, and the total brings us to 1.5 million. So the total for now for all the slab work and everything we've gone through is 74.17 million. Okay, Then going to, I think, the second last thing for the shell of the house. Okay, we have the wall for the walling for the superstructure. These ones are pretty much straightforward, just like I've explained before. Now here we combined the ring beam of here plus also the ring beam of the other part, which is bungalow, which is not the storied part. Okay, so the total for all those, you can see we have all the rings and iron bars and all that, and the total brings us to, if you include the masonry work, the total brings us to about 94 million. Okay, so by 94 million we are at the wall plate on both the first floor and the ground floor for the bungalow part. Then finally, for this video specifically, we remember we are only doing the shell, so we have the roofing part of it. So for roofing, I have the things straight on the screen. You can just look at them. We have lake sand, that is for filling the voids in the ceiling. Okay, the voids, what we usually call engalama, yeah, when we are creating the ceiling. Then we have cement, we have the expanded lathing metal, that is the katimba or the mesh that is used to, you know, to seal off the ceiling. We have 6-inch nails, 5-inch nails and all that. We have then the iron sheets we've considered in this scenario are the ones you actually see on the screen. Okay, the tile profiled iron sheets. Then we have ridges, we have valleys, we have fascia boards, we have rubber washers and all that, as you can see on the screen. And the total for the roofing is about 26.5 million. Yes, those who have done roofing before, for mainly this type of roofing, it can be quite costly. So anyway, the whole total of all this is coming to 120 million. Now that includes everything exclusive of labor. That is basically for the shell of the house. We have no windows, we have no doors, we just have the shell of the house up and standing, plus a roof and a ceiling, and that is all. So this does not involve or include labor charges depending on who is building for you. Otherwise, in the next phase we are going to be discussing the finishing, the plastering and the windows and the tiles and all that. That is a section of construction that is highly variable. Yeah, so that really depends on the choice of the things that you make along the way. But for this part of the shell of the structure, most of the things are kind of standard. It would be a huge compromise to take some things and leave others. Okay, so anyway guys, thank you very much for watching, and please have yourself a good time. I'm DaWinbaği.
Your life, and I lost myself again. You hit just like a drug. This time I won't let you in. You're playing with fire. No, I didn't numb the pain, but this time I won't collapse like I did yesterday.